This is part 1 of the Algebra 1 exam review. Please make sure you have a calculator handy just in case you need it, and possibly a formula chart. So on the first one, you have a truck that's carrying 1,500 pounds of boxes that occupy 138 cubic feet of space. A box containing a television weighs 50 pounds and occupies a space of 4 cubic feet. A box containing a microwave oven weighs 30 pounds and occupies a space of 3 cubic feet. Which system of equations can be used to find the total number of televisions T and microwaves M that are in the truck? So there's two different equations that we have to write. We have to write an equation about the pounds, and then we have to write an equation about the how much space that they occupy. So I know that one equation is going to equal 1,500, and the other equation is going to equal 138. So now we just have to match up how much the television and how much the microwave weighs for the correct equation. So a box containing the television weighs 50 pounds, so I know that needs to go with my 1,500, so 50 times however many televisions are in there, and then it occupies 4 feet of space, so that's going to be 4T. Then if we go to our microwave, microwave weighs 30 pounds, so that's going to go in the pound equation, so 30 times the number of microwaves, and it occupies 3 feet of space, so plus 3M. And from there you just have to find the one that matches, and that one would be C. Number 2, it gives us 2 lines that we have to graph. On line P, it says that that P has an x-intercept of 4, 0 and a slope of 1/2. Well, you have to graph a point before you can move with the slope, so let's graph that at -4, 0, and then the slope is 1/2, so we can count up 1, right 2, up 1, right 2, and down 1, left 2. Okay, so that line's drawn. And then for the next one, the next line says the graph of line Q has a slope of -1 and a y-intercept of 0, -1. Now, even though the slope comes first, you still have to plot that y-intercept first. So that's going to be a -1 on the y-axis. And then a slope of -1, I'm going to go down 1, right 1. So hopefully right there, whenever you see that those 2 points overlap, that answers our question. Name the coordinate that both lines have in common. Well, that point has to be right there at -2, 1. For number 3, we're going to complete the square. So in order to complete the square, you have to take the middle term. So in this case, it's going to be a 16. And you're going to divide it by 2. And then you're going to square that number. So 8 squared is 64. That is what you would have to plug in for C for that to be a perfect square trinomial. Okay. Same thing on B. You take your middle term, which is 18. Notice I'm not worrying about what the sign is right now. You divide it by 2. You get 9, and then you square that number. So 81 would be what you have to plug in for C in order to make that a perfect square trinomial. For number 4, what is the y-coordinate for the solution to the following system? There's 3 different ways we know how to solve for a system of equations. The main 2 are substitution and elimination. You can plug this in the calculator, especially since they are both solved for y, but I'm going to show substitution because that's the best by hand method. So since y equals 2x, I'm going to take this 2x and I'm going to plug it into y in the first equation. So this is going to set us up 2x equals x plus 2. We subtract x equals 2. Now, with the exam being multiple choice, 2 will definitely be an answer, but you haven't answered the question because it says, what is the y coordinate? So you just have to take that 2 and plug it back in, but that's a very easy mistake to make. So You can plug it in either equation. So I'm just going to plug it in the bottom of the equation. So y equals 2 times the x is 2. So y equals 4. Now for number 5, we have to rewrite those as radicals. So the thing you have to remember is that the number on the bottom is going to be your index. So that's the number that, if this is a radical, this number right here, that's going to be your index. So the number on the bottom is going to go right there. So the first thing is going to look like this. It's kind of hard to write, so that's going to be the cube root of b to the 7th. You can also write it like this. The one thing that can be different is that this to the 7th power can also be in one other place. So I still keep my index the same, but now instead of putting the 7 on the inside, I put it on the outside. So either one of those are correct. So depending on what your multiple choice answers look like is going to depend on how you would write your answer. So for b, the index is 5. So when you make your radical, it should go right in that little corner. And then b to the 8th. And then for c, our index is 4. And then that's going to be b to the 3rd underneath the radical. You could also write b and c differently as well. You could say the 5th root of b to the 8th power. And c could also look like this. The 4th root of b all to the 3rd power. On number 6, it shows us a set of inequalities, a system of inequalities, in which quadrants of the coordinate plane is the solution not shaded. So in this case, we need to graph both of these. So they're both in y equals mx plus b, which is nice. So if we start with the first one, we start at -2 on the y-axis, and the slope is 1/2. So we go up 1, right 2. Then you have to decide, is it a dashed or a solid line? You can tell that by looking at the inequality. So if it doesn't have the or equal to part, it's going to be a dashed line. And then lastly, you have to shade. Since it is less than, you have to shade below the line. So that's going to be down here. Now keep in mind that if you have a dashed boundary line like we have right here, that is not included in your solution. Then for our other equation, we have y is greater than -2x plus 8. So I start at 8 on the y-axis. And then our slope is -2, so go down 2, right 1. Once again, there is no or equal to in that inequality, so it's once again going to be a dashed line. But this time it is greater than, so you have to shade above. So you have to shade above the line. So now the solution is where those two shadings are overlapped. So that would be in quadrants 1 and 4. But in which quadrants of the coordinate plane is the solution of the system not shaded? So that would actually be over here in quadrant 2 and quadrant 3 would be your answer. For number 7, match each function with a table that describes the points for that function. The easiest way to do this would be to put it in our calculator. So we're going to put a in y equals, so 2x, and I'm going to make sure I do it exactly the way it is, in parentheses, raised to the -2 power. And then I didn't mean to press graph, I actually meant to press table, so second graph. And then I'm just going to check the table to see which one matches. So 1.25, so it has to be table 3. Then if we do 1/2 x squared, go back to y equals 1/2 x squared. Look back at the table. 1.5, so I know that has to be table 1. And then that leaves table 2 for C. And you can always double check that last one just to make sure. Okay, on number 8, we just need to simplify this multiplication problems that does involve exponents. So I don't have a coefficient in this first number, or in the first term, so 1 times -4 is just going to be -4. Then whenever you are multiplying things with exponents, you add them, so 5 plus 8 is going to be 13, and then C to the, don't forget about this understood 1 on that C, and so 1 plus 3 is C to the 4th, and that's your final answer. Number 9, which operation should be performed to simplify that expression? Well, for the coefficients, 15 divided by 5, you should just divide, so that would be 3. And then x squared over x, you should subtract those exponents. So the answer would be 3x to the first. Make sure you realize that the part that I said where we were dividing 15 by 5 and then subtracting the exponents on x squared over x, that's your actual answer to this one. Number 10, write an expression which would represent the area of a rectangle which has a width of that term, y to the 5th, all raised to the 2nd power, and a length of 2x squared y to the 5th, all raised to the 2nd power. So the area of a rectangle is length times width, so we just have to plug in. So our length is 2x squared y to the 5th, all raised to the 2nd power. And then our width is xy to the 5th, all raised to the 2nd power. So first thing we have to do is we have to apply in the power that's on the outside. So I have to say 2 squared is 4, but whenever I take a power to an exponent, you multiply those exponents together. So that's going to be x to the 4th, then y to the 10th, times, and then I have to do the same thing over here, so that's going to be x squared y to the 10th. Now I have to go back to my multiplication rule. So I have 4 times an understood 1 is 4. When you're multiplying things with exponents, you add the exponent. So that's going to be x to the 6th, y to the 20th is going to be the final answer. For number 11, we are going to evaluate f of -3 for the function given. Even if you're going to put this in your calculator, I highly recommend actually writing it out. So that's going to be 2 times -3 to the 4th divided by 3, not x. We're plugging in a -3 for our x squared. Now, another big hint that I will give you, if you are going to put this in your calculator, you need to do one of two things. Put parentheses around the top and the bottom if you're wanting to put it all in there together. Or I'm going to show you a quick trick in the calculator to actually make yourself the top and the bottom. So if you hit alpha F1, this first one right here, that n divided by d, that stands for numerator and denominator. So if you press that, it's actually going to give you your fraction, and you can type it in. So 2 parentheses -3 caret to the 4th power. Now I'm going to go to the bottom. That's going to be 3 parentheses -3 close parentheses squared. So now it's exactly the way it is on the board. Press enter and I get 6. Now you can definitely do the top separate from the bottom and then divide, or like I said, you can put parentheses around the top and parentheses around the bottom. For number 12, same thing we've been doing, so you just have to simplify. So the numbers in front, the coefficients, 15 divided by 20, that is just can be simplified to 4 over 3. Then we have f to the, that's f to the 3rd power over f to the 1st power, so that's going to be f to the 2nd power. And then you have to be very careful when you're subtracting exponents involving negative. That's going to be g to the 7 minus -2. So that's actually going to be g to the 9th power. Now, the way that the answer is written is perfectly acceptable, but you also need to know that that f squared g to the 9th can also be in top with the 4. So you could also write your answer 4f squared g to the 9th divided by 3. Both of those answers are completely acceptable. So for 13, anything to the 0 power is going to be 1. So that a to the first power is just a 1. So really the only thing that we're having a problem with now, so we have b to the negative second, c times c cubed, is you cannot have a negative exponent, so you have to move it to the opposite of where it started from. So from the top to the bottom in this case, so your c cubed stays on top, your b to the second moves to the bottom. On 14, we have a to the 8th power times a to the negative 8th power. Well, if I add those exponents, that's going to be a to the 0. Anything to the 0 power is just 1. 15, I have a little bit more work to do. First thing I have to do is apply in this 2 to each one on top. So that's going to be w squared x to the 12th, y to the negative 16th, and z to the 6th. Divided by, I'm just going to bring over w squared x to the negative 5th, y to the 4th, z to the 5th. Now, so that on the top on that one, I use the power to a power rule. Now I'm actually going to use the subtraction rule. So when you're dividing things with exponents, you subtract them. So that's going to end up being, my w's actually cancel out. And then that leaves us with x. 12 minus negative 5 is 17. Negative 16 minus 4 is going to be y to the negative 20th. And then z to the first power. You cannot leave a negative exponent, so that's going to move to the bottom. So the final answer would be x to the 17th, z to the first, divided by y to the 20th. In number 16, we are comparing the size of a tennis ball to the top of Reunion Tower. How many times greater is the diameter of Reunion Tower to the diameter of the tennis ball? So if we are comparing, we want to know how many times larger it is. So that means we need to put the one that is bigger on top over the one that is smaller. So we know that Reunion Tower is bigger, so I know that 6.9 times 10 to the negative second should be on top. Tennis ball is 6 times 10 to the negative fifth. Now here you can use your same trick, because if you don't use this trick, you've got to put parentheses around the top and the bottom. So alpha F1, press enter. So 6.9 times 10 to the negative second. And then in the denominator, 6 times 10 to the negative fifth. Press enter. Now, it doesn't say how to write our answer, so the Reunion Tower is going to be 1,150 times larger, but let's also practice writing our answer in scientific notation. Now, the easiest way to do this is to change your mode in your calculator to scientific. Go back to your main screen, press enter. So in scientific notation, that would be 1.15 times 10 to the third power. Okay, on number 17, which of the following is an example of exponential growth? The easiest way to check these, if possible, is to put them in your calculator and look at the graph. And I'll go ahead and give you a hint. If you look at D, it is a great example of exponential growth. So if it looks like that exponential function getting higher, then it's going to be exponential growth. Now, the one that I can see that you cannot do this would be B. This is where you would need to remember your growth formula has a plus and not a minus in it. So here's a good example. There's the plus, there's the minus. This one is growth. This one is decay. So B would also be an example. So let's check A. So go to y equals 23 raised to the x power and hit graph. Now some of these are really, really close to your axis, so you may have to zoom in or out. Now this one I can see pretty good. It starts right here and then it goes up really fast. Well, as soon as you say up, that is exponential growth. If you check C, and actually you really shouldn't even have to check C, because hopefully you remembered if you have an x squared, that is a quadratic, so that's not an exponential growth. We already said D was. If you look at E, hopefully you recognize that that's just an x to the first power, so this would be linear. F is decay because it has a minus. G, I'm not sure, so let's plug it in the calculator. Negative 47 raised to the 3x power. Hit graph. Now, to me, that looks like it came across and went down. Let's zoom in and see if we can see that any better. So I'm just going to zoom in right there at the middle, because remember, it's not going to do anything until you press enter one more time. And I'm looking for it, and I can definitely tell that that's going down. So this would be decay. For number 18, you purchase a cell phone for $125. The value of the cell phone decreases by about 20% annually. Write a function that models the value of the cell phone over time. Then find the value of the cell phone after 3 years. Now, it says use the exponential decay equation, so hopefully you took the time to go back and look in your notes or look it up on the internet. That equation is y equals a parentheses 1 minus, in this case, r raised to the t power. It's a minus in this case because it says decreases by 20% annually. Now, just as a reminder, this a is the initial amount. This r is the rate. And this is the time. And I should say rate as a decimal here. So whenever we start plugging in, y equals, the cell phone was initially $125. Then 1 minus, it went down 20% annually, so 20% as a decimal is 0.2. And then raised to the third power, because we want to know the value after 3 years. So now if we go back and we plug this in our calculator, 125 parentheses 1 minus 0.2 raised to the third power. Oh, I'm still in scientific notation, so I'm going to go back. Press enter. So after 3 years, the phone would be worth $64. And this is your equation. Keep in mind that your equation, depending on how your answer choices look, if you wanted an equation to model it, it could easily have a t there instead of a 3, because specifically after 3 years, you would get the $64. 19, the sum of the following polynomials will sum, and here's one good thing is that you can just ignore those parentheses if you are adding. Now, one thing I like to do is pick my highest exponent and start with that. So I see an x to the 6th power, and that's the only one I see, so I'm going to start with that. Negative 2x to the 6th. Then I have x to the 5th, x to the 5th, so I've got to do 2 minus 7, so that's minus 5, x to the 5th. Just combining like terms. Then we have 3x to the 4th, that's the only 4th term. So plus 3x to the 4th term. And then plus 3x plus 9x plus 12x. Now we need to simplify number 20. Now the difference here is we have some distribution to do first. So I'm going to distribute everything. So x squared times 6x to the 5th, that's going to be 6x to the 7th. X squared times 2x cubed is plus 2x to the 5th. X squared times negative 3x is negative 3x cubed. That's plus 4x to the 5th. Minus 8x cubed. Plus 14x. And then lastly, have to distribute this last one. So that's going to be plus 3x cubed minus 15x. Next thing we have to do is the same thing we did above. We just have to combine like terms. So I've got 6x to the 7th. I don't see another x to the 7th, so I bring it down. Then I don't see an x to the 6th, so I'm going to move to x to the 5th. So that's going to be plus 6x to the 5th. Then I don't see an x to the 4th, so I'm going to do my x cubes. I notice that those two cancel out, so that leaves us with minus 8x cubed. And then finally, our x terms, a 14 minus a 15 is negative 1x. For 21, we have to multiply those two binomials, so you have to double distribute or FOIL. So 3x times x is 3x squared. 3x times negative 8 minus 24x plus 4x minus 32. So if we combine like terms, that's going to be 3x squared minus 20x minus 32 simplified. For 22, we have to simplify both of those division problems. I think it's best because you have to put this denominator with the top and the bottom. Go ahead and rewrite it so you can focus on simplifying both of those. So over here, the 5 over 2 doesn't reduce, but this will reduce to just an x, so that's 5x over 2. Minus 10x over 2x is 5. Same thing over here, 3x squared over 3x minus 9 over 3x. So that those 3's cancel. We're left with an x on the left. Minus 9 over 3 is a 3. But you still have that x in the denominator, so that's going to be your final answer, x minus 3 over x. 23, Dirk is putting in a pool, or putting in a deck around his rectangular pool. The dimensions can be expressed by 2x plus 5 and 5x plus 2. The outside dimensions of the deck can be expressed by 4x plus 9 and 7x plus 5. The easiest thing to do is draw a picture. So here's the pool. Here's the deck around the pool. Now I'm going to write the dimensions from the problem. So the dimensions of the pool can be expressed by 2x plus 5 and 5x plus 2. Then the dimensions of the outside dimensions are 4x plus 9 and 7x plus 5. So it says express the area of the pool as a polynomial. Well, I'm going to have to multiply those dimensions. So that's 2x plus 5 and 5x plus 2. So if we double distribute, 10x squared plus 4x plus 25x plus 10. So the area of the pool in terms of x is 10x squared plus 29x plus 10. And then it says express the area of just the deck. Now before we can jump to the deck, we actually have to find the area of the whole entire thing, so then we can subtract the area of the pool. So the area of the total area, we could say, is going to be 4x plus 9 times 7x plus 5. So that's 28x squared plus 20x plus 63x plus 45. So then we combine like terms in the middle. So the total area is 28x squared plus 83x plus 45. Last step, we have to subtract. So we have to subtract the total and I'm going to kind of add it on here just so that I have a little bit less stuff to write. So I'm going to say minus, and then I'm going to take the area of the pool. 10x squared plus 29x plus 10. Now I put that in parentheses on purpose because that minus applies to all the terms. So you actually need to distribute that. So you would have 28x squared plus 83x plus 45 minus 10x squared minus 29x minus 10. So finally, the area of just the deck equals, so if I put my x squareds together, that's going to be 18x squared. Then our x's is going to be 83 minus 29, so that's going to be plus 54x. And then 45 minus 10 is plus 35. That will be the area in terms of x of just the deck. Okay, number 24, if the area of a rectangle is 12x squared plus 8x minus 15, express the length and the width in terms of x. Well, the only way to break up a trinomial is to factor it. So the first thing that I think to look for is the greatest common factor, but unfortunately there is not one, which means I'm not going to be able to use the shortcut because a equals 12. So we're going to start this process, so you have to do a times c, which is going to be negative 180. Because remember, the purpose of this is to get two numbers that will replace this 8x, so that we'll have 4 terms instead of 3 terms, so that we can factor by grouping. Now, just to remind you, the trick in the calculator to help you find those factors, you do 180. Notice I didn't put the negative in there. You have to add those yourself. 180 divided by x. And if we look at our table, we're looking for two numbers that will add to give us an 8. So if we go down, don't see anything yet, but right there, 10 and 18, but I know one of them has to be negative because I need them to multiply to give us negative 180. So since the 8 needs to be positive, it has to be a negative 10. So now we are going to replace that positive 8x with a minus 10x plus 18x. And here's the thing, it doesn't matter which order you write these in, it should work. So we have 12x squared minus 10x plus 18x minus 15. Now we group first two, last two, and take the greatest common factor out of each of these. So out of the first one, the greatest common factor is going to be a 2x. We have to divide by 2x to get our leftovers. So that's going to be 6x minus 5. Out of the second parentheses, we can take a 3, so a plus 3. If we divide both of those by 3, we're left with 6x minus 5, which is a good thing because those parentheses have to match. So that makes our final factored binomials 6x minus 5 times 2x plus 3. For 25, we're just looking for the greatest common factor of that trinomial. So let's look at the numbers first. So we have a 4, a 24, and an 18. Well, because 4 won't go into 18, can't be 4, but they're all even, so 2 will go into each of those. Then we have to look at each of the variables that they have in common, and then look for the lowest exponent. So that's going to be x to the first power, and then y to the second power, because 2 is the lowest exponent. For 26, determine the binomial factors of x squared plus 8x plus 15. After that number 24, I'm excited because you can do the shortcut on this problem because a equals 1. The steps are still the same, there's just less steps. So 1 times 15 is 15. Then you need your two numbers that will add to give you 8. So that's going to be a 3 and a 5. Now the awesome part about when you can use your shortcut is that these are going to be the numbers in your parentheses. So it would be x plus 3 times x plus 5. For 27, we need to factor that polynomial. And I know 361 and 81 are kind of big numbers, but you do need to check to see if anything will go into those. So first thing I notice is that I know 9 will go into 81, so I'm just going to double check. 361 divided by 9, and that doesn't go evenly. So next thing I'm going to check, since there's two terms, is maybe it's a difference of squares. So I need to check to see if 361 is a perfect square. And it is, and I know 81 is a perfect square, and I know y squared is. So once we have determined, like we just did, that it's a difference of squares, you can write your two parentheses. Square root of 361 y squared is 19y. Square root of 81 is 9. Then we have a plus and a minus. 28 we have to factor completely, which is what we've been doing. First thing I notice is that there is a GCF, so I can take a 10x, and the lowest exponent is 4, so 10x to the 4th. And so I need to divide all of those by 10x to the 4th. So we are left with 6x squared plus x minus 2. Now, anytime you have a trinomial left over and it says factor completely, you have to see if that's factorable. So we have to start this process. A times c, so that's going to be negative 12. And see if there's two numbers that will add to give you a 1, and there is 4 and negative 3. So we have to keep factoring this. So we have 6x squared plus 4x minus 3x minus 2. We need our parentheses. So first two, last two. Notice I haven't done anything with this 10x to the 4th, but I'm definitely going to make sure that it's in my final answer. So out of our first parentheses, we can take a 2x, then 3x plus 2. Then here, they're both negative, so I can take a negative 1. So we're left with 3x plus 2. So our final factored form is going to be 3x plus 2 times 2x minus 1. And please don't forget about your original GCF, because that needs to be out in front. For number 29, find the 7th term in the sequence a sub n equals 3 times n minus 1 to the 3rd power minus 2. A sub n means that n is going to be our 7. So we just need to plug in 7, and you can do one of two things. If you want to put that in your calculator, you can, but it's pretty straightforward. So a sub 7 equals 3 times 7 minus 1 cubed minus 2. I think I'll put this in my calculator. 3 parentheses, I know that's a 6 to the 3rd power, and then minus 2. And so the answer is 646. For 30, what are the solutions to the equation given? And solutions, just as a reminder, those mean several things, or several words mean solutions. Zeros, roots, x-intercepts. So keep that in mind, as that could be worded either way. But I think the key is that your x-intercepts are x comma 0. So I hope right now you recognize that it can't be that one and it can't be that one, because those are actually y-intercepts. So now we just have to check and see if those are where that function crosses the x-axis. So 2x squared plus 9x minus 5, and now I'm going to graph. Now I'm zoomed in from earlier, but that actually helps me right here, because I can tell that's 1/2. So then if I zoom 6 to go out, remember we already saw close up that that's 1/2, and this is 1, negative 1, 2, 3, 4, 5. So 1/2 is a solution and negative 5 is a solution. So it would be 1 and 3. For 31, we have to divide those, and hopefully you recognize that if you have a trinomial on top, you've got to break that apart somehow. So we are going to factor. It is kind of just a shortcut, so it should be a little bit easier. So 1 times 45. Then you need two numbers that add to give you a negative 14. So I know that this is going to be 9 and 5, but they're both going to have to be negative. So this top part, will factor to x minus 9 times x minus 5. And then I'm going to bring over my x minus 5. They match, x minus 5, so they cross out. So x minus 9 would be your final answer. Number 32, a part of the graph of that equation is shown on the coordinate grid. One solution crosses the x-axis between 9 and 10. So I can tell that this one, that's this right here. Between which two integers is the other solution located on the graph? And you may be thinking, well, they forgot to put grid marks, but that's actually on purpose because we want you to use this equation and find that other zero. So plug that into y equals, so 1/2 x squared minus 6x plus 23 over 2. Press graph. So now we have that exact same picture over here, and 1, 2, 3. So I can tell it's between 2 and 3. I'm going to go through the process of actually finding it just for practice. Second trace, number 2 for 0. Then I'm going to get as close as I can because I need to set my left boundaries by pressing the left arrow key. Then the right boundary by going just to the right of that x-axis, enter, enter. So that one is 2.3, so it would be between 2 and 3. For 33, which best describes the differences between those two graphs? So you can put these in your calculator, but you also need to remember you can memorize the shifts that we learned for these quadratic graphs. So if you're going from the number in front of x squared from a 1 to a 3, if it's getting higher, then it's going to be more narrow. Then if it's going from a +5 to a 7.5, or a +7, it is going to shift up. So I'll show you what that looks like in the calculator. So put in x squared plus 5. Then in the second one, we're going to put in 3x squared plus 7. Press graph. The first one is the first one, so that one's at 5. The second one is shifted up. It's actually kind of good that we know that for going from a 1 in front of x squared to a 3 is narrower because that is very difficult to see on this graph. Now keep in mind, you could always change your y minimum and y maximum so that you could see more. So if we graph, there's the first one, there's the second one, so you can tell them if you know to change those things. Okay, the second one, how would you change the graph of the parent quadratic function? You've got to know that that is y equals x squared to produce that graph. Well, if I go from y equals x squared to y equals x squared minus 12, so I went from a 0 to a minus 12, that means you have to shift down 12 units. 34, describe the aspects of the graph of the given function. So, and here's a little trick. If you want to double distribute that and simplify it, by all means, but you can actually put it in your calculator exactly the way you see it, just to make sure you don't make any careless mistakes. So now we can graph. Remember, I just changed my y-axis, so that's actually a pretty good picture anyway. Does it open up or down? So it opens up. If you had not put it in the calculator, you can tell because it is positive in the front. Okay. What are its x-intercepts? Well, let's find those zeros. So left, right, enter. So the first one is negative 1.5. And then if we do the second one, left boundary, right boundary. So the second one is 5. Vertex, same start, second trace. This time, I should have looked, it's a minimum. Second trace, number 3 for minimum. So I'm going to go down here to the lowest point. Remember, you have to be left of that point for your left boundary and right of that point for your right boundary. Enter, enter. So our vertex, which is an ordered pair, is 1.75, negative 21.125. And then finally, the axis of symmetry, you can actually take from that vertex. So the axis of symmetry is going to go through that point, so it's x equals 1.75 is the axis of symmetry. For 35, it's the same concept, except we only want the vertex, so that's your minimum or your maximum. 2x squared plus 8x. Look at the graph. I can still leave it, remember, and I'll hit zoom 6, just because you can always do that if you want to. So second trace, minimum. I'm going to go down to the lowest point, go left, enter, right. So I'm looking for my cursor to go above that point, enter, enter. So that's going to be, the vertex is negative 2, negative 8. Okay, 36, which of the following is the correct representation of the quadratic parent function, which we know is y equals x squared? If you don't, you definitely need to memorize that. And hopefully you recognize that that is D. Linear parent function is y equals x. So that has to have a positive slope, which would have to be a. And goes through 0, 0. Both of our parent functions touch the origin. 37, Edward sees Bella has fallen out of a tree and he leaps to save her. The height with respect to the height of his leap with respect to time can be modeled by that equation. Approximately what times is Edward at the height of 100 feet? So we've got to put that function in our calculator. So negative 10 x squared plus 70 t, so x. And then if you want a specific, at what height at 100, or when is Edward at a height of 100 feet, we need to go to the table. So here's our table, and you can see at 2 seconds and at 5 seconds, Edward's at 100 feet. Now here's what I don't want you to do. It says, what is his maximum height? Look here, both of these are 120, but I don't want you to think that's his maximum height. So if we actually go and find his maximum height, well, I know I need to change my window. And I know I saw 120 on my graph, so let's do negative 150 and 150. Hit graph, and let's see if that's a better picture. Much better, so that's a maximum. Second trace. Maximum, so I'm going to come up here to the highest point. So I'm going to go left, right, and then finally enter, enter. Now, make sure you're answering the correct question. What is the maximum height is going to be the y value. If it said when is he at his maximum height, that would be 3.5 seconds. So what is his maximum height is 122.5 feet. For 38, use the quadratic formula to solve that given equation. Express our answer in radical form and round it to the hundredth. So here's where you could use your chart. Before we can even use our chart, we have to subtract 5 from both sides. So x squared plus 3x minus 5 equals 0. So A is 1, B is 3, C is negative 5. So then we can start using our formula. So x equals the opposite of b. That's how I say that first part, negative b. The opposite of b is negative 3 in this case, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 5, all over 2 times 1, because a is 1 in this case. Now, one thing I want you to be very careful about, if our b value would have been negative, it would have been a must that you put parentheses around that negative before you square it. Now, my recommendation is, since you have to write this in radical form, is going to be to put all of this in your calculator. So your next step would look like this. -3 plus or minus, you're going to get a number under your radical over 2. So I'm going to put 3 squared minus 4 parentheses 1 parentheses -5. So exactly what's underneath that radical without actually putting that radical in my calculator. So I get 29 is the number under the radical. Since that can't be simplified, that satisfies our A answer choice. Now, when I need the other two rounded to the 100th, I'm going to have to do this twice, because remember, you have to have 2 answers since we have this plus or minus. Okay, so you're going to have to break it apart. The first one would be -3 plus root 29 divided by 2. The second one is going to be -3 minus root 29 divided by 2. You can use that neat trick about the numerator and denominator and put those in. So the top one's -3 plus root 29 divided by 2. So that's 1 point, and it says to the 100th, so 1.19. And then the other one, I'm going to see if this will work. So I'm going to grab that, and then I'm going to go back and see if I can just change that to a minus. Oh, that was easy. And -4.19. So now we have our answers for A and B for 38. For 39, how many zeros, x-intercepts, do each of the following graphs have? How can you find out without solving the quadratics? Well, you can use the discriminant. It is on your chart, but the easiest way to do this is to plug it in your calculator and see how many times does it cross the x-axis. So press graph. Now I can't tell, so I'm going to have to zoom 6 and just start with a clean window. Well, that I'm glad I did, because it definitely crosses at 2 places. So there would be 2 solutions to A. If you check B, graph does not touch the x-axis, so that would be no solution. And then finally, the last one, you might have to zoom in on this one. Let's see what happens. So x squared minus 6x plus 9, hit graph. Now, if you're not 100% sure if that touches once or twice, so I'm going to zoom in, and you can see me moving my cursor over to where it touches, and I'm going to press enter. Now I can tell 100% that that parabola does not dip below that line, so this would be one solution. Remember, if you want to review how you can tell without having to plug it in your calculator, you would want to practice finding the discriminant to see how many solutions that it has. For number 40, given that function, find the following. So we need to put this in our calculator. So we have 4 to the x power minus 3. I'm going to press graph. Definitely going to have to zoom 6. Zoom 6. Now, in our exponential function, since it goes all the way from the left to the right, it's going to touch every x value possible. So the domain is going to be all real numbers. Now, the range, you can see this is our lowest y value that you have. And if you count 1, 2, 3, and it doesn't even, remember, this line is called an asymptote. It doesn't actually touch the -3 on the y-axis. So our range is going to be all y values greater than -3. Notice this little -3 at the end kind of gives you a hint as far as that goes. Our y-intercept, you can always, and this is a kind of a trick in the calculator, if you press trace, 99% of the time the cursor is going to start at your y-intercept. So look, 0, -2. So that is our y-intercept. And then finally, the asymptote that I was talking about, in this case, is a horizontal line at -3. So that's going to be y equals -3. For number 41, we're going to use the graph to the right. The domain of any quadratic function that we have in Algebra 1 that opens up or down is going to be all real numbers. Remember, when you get to Algebra 2, that may not be true because you'll have quadratics that open sideways as well. Then for the range of the quadratic function, we want to know the highest or lowest point. In this case, it's going to be highest. Remember that if you get this vertex, so I'm just going to write the vertex as 0, -2, that you can use that y coordinate of your vertex in your range. So y and -2, and then you have to decide, is your graph greater than -2, which would look like this, or less than -2, which is what we have. So it's going to be less than or equal to -2 would be the range of that function. Now we have some radicals. So 153. Now, 153 is not a number that we see a lot, so if you grab your calculator, you can use your trick to find your factors. So I'm going to go to y equals, clear out that calculator, and do 153 divided by x. Second table, now I'm going to look for the largest perfect square. Now, even though I'm only showing that one side, I'm also looking at any whole number on the y column as well. So I'm going to keep going down and check any whole numbers. And right there, 9 and 17, that's going to be my largest perfect square. So 9, 17. Can't leave that 9 under the radical, so the square root of 9 is 3 times the square root of 17. Row number 43, we have multiplication. Remember the rules: outside times outside, inside times inside. Since you have both insides, you can multiply those first. You could simplify first. It's really up to you. So I'm going to multiply first. So that's going to be the square root of 270. That'll give us a chance to practice our trick in the calculator. So 270 divided by x. And then I'm looking for the largest perfect square. There's 9 and 30, and I think that's going to work. So 9 times 30, can't leave the 9 under the radical, so the square root of 9 is 3, and then the 30 is left underneath the radical. On number 44, can't break the 5 down because there's no perfect square, so I'm just going to bring it down. A to the 4th is a perfect square because the exponent is even, but then anytime you have an odd exponent, you break it down into one less than what the exponent is, so that's going to be b to the 10th times b. So then I circle any perfect squares, so a to the 4th, b to the 10th. Remember, when you're taking the square roots of anything with an exponent, you half the exponent. So that's going to be a to the 2nd, b to the 5th, times the square root of 5b. On number 45, we have to double distribute. So we've got 3 times 4, so 12. Then we have 3 times the square root of 2, so plus 3 root 2. Then we go underneath for the double distribution. So that's going to be negative root 2 times 4, so that's minus 4 root 2. And then finally, negative square root of 2 times square root of 2 is minus square root of 4, but remember that trick: if you multiply a square root times itself, it's just going to, the number inside is going to come out. So now we can combine like terms. So those are the middle, and then our two constants. So that's going to end up being 10 minus root 2. On number 46, one thing that you can do to help yourself anytime that you have a fraction underneath your radical is check to see if it'll reduce. Okay, now it's not necessarily the best thing to do here, and I'll explain why in just a second. And And then math, enter. Oh, well, you can simplify it. That's fine. Either way, you're going to get the same answer. So when I simplify that, you end up with 16 over 9 underneath your radical. Well, both of those are perfect squares. So then you can just, got to circle both of them. So square root of 16 is 4. Square root of 9 is 3. So the final answer would be 4/3. Notice that is not underneath the radical. You could have also in this one, because 144 and 81 are both perfect squares, well, the square root of 144 is 12. The square root of 81 is 9, which once again reduces to 4/3. On 47, remember when you add or subtract things with radicals, they must have the same radical, the same simplified radical underneath there. Well, 5 is simplified. They're all square roots of 5, so I just need to add the numbers, add or subtract the numbers in front. So 3 plus 2 is 5, minus 7 is -2, and you keep that root 5 with that -2. We got to break these two down. 48 can be broken down into 16 times 3, so that's going to simplify to 4 root 3. 75 breaks down into 25 times 3, so plus 5 root 3, so 9 root 3. For 49, which expression is equivalent to 3x over root 3? Well, that root 3, you can't have that in the denominator, so you need to rationalize the denominator by multiplying by square root of 3 on the top and bottom. So the top becomes 3x root 3 over, remember our trick, square root of 3 times square root of 3 is just a 3. Well, the 3's on the outside cancels out, and you're left with x times root 3, which is a. And the last one for part 1, Ernest plans to paint a small rectangular wall on his apartment as shown. To the nearest integer, how long is the diagonal strip that separates the two colors? Also write your answer as a simplified radical. So this is just Pythagorean theorem if we need this hypotenuse. So that's going to be 3 squared plus 8 squared equals c squared. So 9 plus 64 equals c squared. So that's going to end up being 73 equals c squared. To get rid of a square, you take the square root. So c equals the square root of 73. That can't be simplified, so this is your simplified radical. If we need our answer to the closest integer, square root of 73, enter. So c is approximately, and I know it says integer, but I'm going to go ahead and just round it to the 10th, 8.5, keeping in mind that would, to integer, it would round to a 9.